Hello everyone, myself Shampa Chaudhuri Mukherjee. Welcome to Maria's virtual classes. I am the teacher of physics and today I am going to teach you the topic work, power and energy for ICSE. This particular topic has 10 to 12 marks in boards. Now, as you can see in this first slide, work, power, energy. How it is related? It is related afterwards in mechanics and it will be useful in that when we will study about mechanics. Now, work, power, energy's first topic, that is understanding work. Today we will discuss about this particular topic of understanding work. In terms of physics, work done is said to be considered when there is a displacement in the body after applying an external force. Now, if there is no displacement produced in the body, that means no work is done. Just for an example, let us consider if a person is pushing a wall, will be any work done? No. There is no work done as the wall is not getting displaced from its initial position. Similarly, when a cool is standing with the load on his head, he is also not doing any work. Though his feet are aching, still he is doing no work. It is because that the work done is considered to be zero. Why? Because the load is on his head and the angle between the force applied and the displacement is 90 degree. So it is simply perpendicular to it and hence no work is done. We will discuss about this matter afterwards. Now, as I have already said about the definition of work done, that is, in physics, work is done when a force causes an object to move in the direction of the force. What is the importance? That one also I have already said. That understanding work is essential for studying energy and mechanics. Now, what should be the formula for work? If every time work done is not same, that means force applied and the displacement, these two things may not be in the same direction. Like for example, work on this. W equals to F into S. W is the work done, F is the force applied on that particular body and S is the displacement produced in that particular body in the direction of the applied force. Now every time we don't find this simple equation. Why? It is because sometimes in certain cases you will find that displacement is not parallel or along the direction of the force. Like for this case only, as you all can see. That W, that is the work done, equals to force into displacement multiplied by cosine of the angle theta. Now over here, in this particular diagram, you all can see that force is applied along this horizontal direction, but displacement is produced in this angular direction. So body is getting displaced from point A to point C. So if I want the component of the displacement along the direction of the force, we have to take this angle theta. So what it will be? It will be S cos theta. How are we getting this? We are going to understand this more minutely. So let us consider this particular diagram roughly. Here is the body kept. It is producing a displacement and it is getting displaced at this position B. Over here we have considered this as A, this as C and this as B. Now, this theta angle is along this horizontal line. Force is applied along this horizontal line. So, to get this AB, work done will be given by F multiplied by AB. But you all can see that displacement is not along AB, it is along AC. So how to get that component? To find AB, we will derive this. All of you know that cos theta equals to AB, that is the base, by hypotenuse, that is AC. Similarly, over here you can see that cos theta equals to AB. AB will remain as it is, whereas AC we consider as S, that is the actual displacement that is produced in that particular body. Now, let us just cross multiply this thing. So, we will get AB as S cos theta. So, students, it's so easy. Now, we are going to replace this value in this position, in this equation number 1. So, W is turning out to S cos theta. This is one way of getting the work done. Similarly, we can get this work done in considering the force and its component. How it is so? In that case, work done will be given by F cos theta multiplied by the displacement produced. In that case, we consider the component of the force along the direction of the displacement. In both cases, we are getting the work done. Now, students, let us consider the units of work done. What are the units? SI unit of work done is joule. 1 joule equals to 1 Newton meter. Similarly, in CGS unit, we have erg, that is 1 joule equals to 10 to the power 7 erg. How are we getting this thing? This is also very much simple. So let me erase this position. Now 1 joule of work done, 1 joule of work is done, and I am telling that it is 1 Newton meter. Student, 1 Newton means 1 Newton into 1 meter. That means 1 Newton is how much dyne? It is 10 to the power 5 dyne, as you already know. And 1 meter, if I convert it into centimeter, we get 100 centimeter. So we have 100 centimeter. And from the laws of exponents, as you already know, that is 10 to the power 5 plus 2 dyne centimeter. What is it? That means 10 to the power 7 erg. So 1 joule is turning up to 10 to the power 7 ergs. Now there are different conditions of work. What are they? See, every time as I said that work is done, we think, but it is not done. Like if you are memorizing a lesson, is it any work done? No. There is no displacement produced in the body. Hence, no work is done. So there are certain cases we will see and we will get into it. For example, example number 1, pushing a box across the floor, yes, work is done. That is along the direction of the motion only, the displacement is getting caused. Similarly, for example, to lifting a weight, also we have force applied that is vertically upward. So no work is done if there is no movement or if the force is perpendicular to the direction of movement. Now, as you have already come to know that W is not only F multiplied by S, that is force multiplied by displacement. It is much more than that. That is force multiplied by displacement into the component of the other displacement or component of the force applied. So cos theta we have to consider. So as per the angle theta, the work done we will find out. Now, as per the my explanation, as I can just show you over here. What is positive work? Positive work is that when the force and displacement are in the same direction, that means theta is 0. So here you all can see forces are applied in this direction, as well as displacement is also occurring parallelly to this direction. So what is the angle in between them? Theta turns out to be 0 degree. From the trigonometrical table also you all know that cos theta or cos 0 degree is 1. So in that case we have W equals to, in that case we have W equals to F into S cos theta, where theta is 0 degree, and as it is 0 degree, cos of 0 degree it is 1. We have the positive work done in this case, in this first case, as I have discussed. Similarly, negative work is also done. How it is so? Where theta angle is considered to be 180 degree. So simply we will replace in place of theta 180 degree and we get it as minus 1. So W equals to F into S cos 180 degree. That means F into S minus 1. We have negative work done over here. Now you may be asking me that negative work, is it possible? Yes. For example, when we are walking on the floor, we need to push the ground backward, isn't it? That's the force of friction. In that case, negative work is done. Similarly, zero work is also done. What it is? For the zero work done, theta has to be 90 degree. That means displacement in the body produced and the force, there should be 90 degree. That means the angle theta should be 90 degree. So let us replace that value and get the answer. So now we are going to write cos 90 degree. So here we get it as 0. Why it is so? Because all of you know that cos 90 value is 0. So work done is 0 joule over here. Now students, here you have understood positive work done, negative work done, as well as zero work done. Work is done in daily life. In fact, now I am also doing certain work. For example, lifting groceries, work against gravity. Similarly, pushing a stroller, horizontal work is done. Cycling, work done against friction and air resistance. So as we have discussed this topic that W equals to F S cos theta, we need to solve a problem also. What it is? A person pulls a slate with a force of 50 Newton at an angle of 60 degree to the horizontal. The slate moves 10 meter and we are going to calculate the work done over here. So W equals to F S cos theta. Here theta has been replaced by 60 degrees. F, that is the force applied, it is 50 Newton. S, that is 10 meter displacement, and we get the work done as obviously positive, and that is 250 joule. So here we have discussed one problem so that you can have a clear idea on how to calculate the work done. Now students, let us summarize this entire thing. What are the key points that you have to keep in your mind? First point, work is done when a force moves an object. That means no displacement, no work is done. Second point, the amount of work depends on the force, distance and the angle between them. So as you have already come to know that it is not simply only the force, only the displacement, but also F as cos theta. So cosine of the angle has to be considered in this case. And thirdly, positive, negative and zero work are different scenarios depending on the direction of force and displacement. To our channel and hit the notification bell. If you like our videos and whatever informations we are sharing over here, quite interesting, do comment in the comment box, and please visit the website www.marias.co.in. I think you have found this session most interactive and informative also.